Maintaining awareness of other users is essential for collaborating effectively. This can be difficult, especially when other users are not working in the same part of the workspace. In 2D workspaces, several techniques, such as the radar view, the telepointer, and view rectangles, shown here in this system, have been developed to maintain awareness of where other people are located and what they are doing. However, in 3D workspaces, the awareness problem is more complex, and the techniques that have been developed so far do not work well when users become out of view, distant, or are facing away. Embodiments are visual representations of other users in 3D space. These are the primary indicators of location, perspective, and proximity. However, when embodiments are out of view, this awareness information is lost. Additionally, perspective awareness can be lost when embodiments become distant or when they are facing away. We developed several techniques designed to help maintain awareness in 3D workspaces. These techniques fall into three categories: embodiment enhancements, participant list enhancements, and alternate views. Embodiment enhancements are extensions to the embodiments that travel with the embodiments as they move. The nose ray is a long-colored ray that extends from each embodiment's head in the direction it is looking. It is effective at showing location and perspective, even when users are out of view. The view cone is a translucent cone that encompasses the approximate area that is viewable by the user. The shape of the cone points to the locations of the users, and the taper of the cone indicates proximity. The headlight is a colored spotlight that shines on all elements that are viewable by the user. It is a more discrete technique for maintaining awareness of location and perspective. One problem is that these methods can lead to significant screen clutter. To reduce clutter and increase the effectiveness of these techniques, we added user controls. On-off switches allow the enhancements to be used alone or in different combinations for each user. An awareness slider lets users set the presence of the enhancements for each user. This essentially brightens and dims the embodiment enhancements. Levels can be set differently for each user, and changes do not affect other users' displays. Participant list enhancements use the space allocated to the participant list to convey more awareness information. The rotating participant enhances awareness of the orientation of the users in the workspace. Watch how the model of the red user in the participant list rotates as the red user moves. This rotation shows the orientation of the red user in the workspace. Alternate views provide the user with a completely different view of the workspace. The Grand Tour, shown in the top right-hand corner of the screen, is an alternate view that provides a low-fidelity third-person view of the entire workspace. Since the Grand Tour captures the whole workspace and the Grand Tour is in a small window, it would not be possible to see all elements clearly. To compensate, the Grand Tour enhances landmarks and embodiments and removes all other details. Since it is difficult to see relative positions of objects in 2D projections of 3D space without relative motion, the Grand Tour remains in constant motion. One of the user tests that we ran was to identify artifacts in a large 3D dataset. Once a feature was identified, the person who found it had to show it to the other participants. In this scene, the blue user has located an artifact and would like to show it to the other users. The red user starts by identifying location, perspective, and proximity of the blue user using the view cone. The view cone is then swapped for the more discrete nose ray. The blue nose ray acts as a guide to help the red user navigate toward the blue user. The appearance and angle of the green headlight indicates that the green user is also approaching. This is confirmed with a glance at the Grand Tour. The rotating participant in the participant list shows that the green user is oriented upside down. We have presented several techniques for supporting awareness in 3D workspaces: the nose ray, the view cone, the headlight, the embodiment enhancement controls, the rotating participant, and the Grand Tour. Our experience with these new techniques has shown that they are effective at supporting awareness of locations, perspectives, and proximities of users who are out of view.